Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nur Amirulhaq bin Muhammad Yusof. For the FKMP student, we present about my PSM 1, which is effect of the radiation temperature and electricity of a bubble column reactor on the bubble size for biodiesel production. So we proceed for the chapter 1 introduction. For the introduction, it consists of background of study, problem statement, objective of study, scope of study, and significance of study. For the background of study, the beginning of the biodiesel production in the worldwide is due to the rising price and the demand for the crude oil to be used as energy in the world economy. Thus, the development of the liquid biofuel being generated from renewable energy, such as from edible oils and non-edible oils. Next, the transesterification reaction occurs in a reactor for production of biodiesel. The transesterification reaction is a combination of the triglyceride, which consists of vegetable oils, animal fats, and wheat and alcohol, typically methanol, as a reactant with presence of catalyst, which is hetero or homogeneous catalyst. You produce the biodiesel and the glycerol. So this study being conducted to determine the effect of the various reaction temperature and inlet velocity on the bubble size in bubble column reactor. The study of the bubble size we perform by computational fluid design simulation. Next. Next, for the problem statement, the size of bubble produced in the bubble column reactor in transesterification reaction will affect the productivity of biodiesel. Thus, various reaction temperature and inlet velocity used to determine the size of bubble produced in bubble column reactor. Either it will increase or decrease the productivity of biodiesel production. Now we continue for the objective. The objective is to identify the effect of various reaction temperature and inlet velocity on the bubble size in the bubble column reactor for transesterification reaction. Second, to conduct a simulation of biodiesel production in the bubble column reactor by using a various temperature and inlet velocity. Next, to study the transesterification reaction in the biodiesel production. So now we continue to the scope of the study. The computational fluid dynamic CFD simulation will be conducted to identify the effect of various reaction temperature and inlet velocity on the bubble size in the bubble column reactor for the transesterification reaction. Next, the inlet velocity of the bubble column reactor is fixed at 2 mm per second. 2 meter per second. The temperature for the reaction ranging from the 523 Kelvin to 563 Kelvin. The software used in Ansel Fluid and SolidWorks 2018 software. Next, we continue for the significance of the study. For the significance of the study, the size of bubble are related to the productivity of biodiesel production. Thus, the importance of this study is to learn and discuss about the effect of a reaction temperature and inlet velocity on the bubble size in the bubble column reactor for transesterification reaction. Besides, this study can help to provide understanding in the process of transesterification reaction for biodiesel production. The quality and quantity of the biodiesel production will be identified by study this project. So we continue for the chapter 2. Now we continue for the chapter 2, which the literature review consists of the transesterification reaction, bubble column reactor, effect of bubble size, and CFD simulation. So we continue for the transesterification reaction for the biodiesel production. So there are 4 methods of biodiesel production, which are blending or dilution, microemulsification, pyrolysis, and transesterification. The transesterification is one of 4 methods of the biodiesel production that we use in this study. So the transesterification reaction are the reaction between triglyceride and alcohol as the reactant with catalyst to produce biodiesel and glycerol. The production of the biodiesel can be produced from edible oils and non-edible oils, which is the edible oils is mostly used in the production. This is because the usage of the edible oils in production of biodiesel can raise the retail price of edible oils and biodiesel, while for the usage of the non-edible oils can increase the quality of the production rate. Biodiesel has a lot of benefit to environment and society, which using the biodiesel has a content of low toxic and good for the environment and society. Next, we continue for the bubble column reactor. The bubble column reactor is the transesterification reaction occur in the bubble column reactor will produce bubble from oils which be heated in the high temperature. The temperature used in the bubble column reactor for transesterification is one of factor which can provide high productivity and yield of the biodiesel production. The design of the bubble column reactor also important in improve the efficiency of biodiesel production. As you can see in the figure shows in this on the slide, the result of the mass of the product change on the various temperature, the increasing of the reaction temperature, the increasing the mass of the product. Next, we continue for the effect of the various temperature and the inlet velocity on the bubble size. This figure based on the computational fluid design simulation of the bubble column reactor with different type of temperature on the previous research show the result. Based on the result, the red color means the vapor volume fraction, which represent the methanol bubbles. So as you can see, the increasing of the temperature reaction, so the number of bubble decrease, and the decreasing of the number of bubble will increasing the gas holdup. So there are the relationship between the gas holdup and the bubble rising velocity, where the increasing of the bubble rising velocity, so the decreasing of the gas holdup, which will produce the largest size of bubbles. So the rise in operating temperature contribute to an increasing in the gas holdup, which show in the figure on the slide. The increasing of the temperature, the increasing of the gas holdup. The higher temperature, the increasing of the gas holdup, the smaller size of the bubble produced. And now we continue for the chapter 3, research methodology. We consider flowchart, design of bubble column reactor, meshing, quality of mesh, boundary condition and sustainability. For the flowchart, these are the flowchart of this study that explain detail of the process from beginning to the end. So, design of the bubble column reactor. These are the design of the bubble column reactor that we designed in SolidWorks 2018 based on the parameter on the slide. This also consists of the obstacle which design spangle. So after we design the bubble column reactor in SolidWorks 2018, we will import into assist fluid to generate the mesh. So we generate 3 type of mesh, which is coarse, medium and fine meshing. So to know the good quality of the meshing model, we determine the quality based on referring the mesh matrix spectrum. So the best result of the meshing model can obtain based on the highest of node and element of the models. The highest of node and element for the final mesh can provide the data efficient fluid flow. So for boundary condition, these are the boundary condition that we use to run the simulation in the ANSYS fluid software. For sustainability, for the element in sustainability, there are three types of element: environment, economy, social. And the concept of the sustainable development, which we conduct the simulation without compromising the ability of the future generation to meet their own needs. For the impact of the engineering solution to sustainable development, which reduce waste since we conduct the simulation. The simulation of this project is relevant for the improvement of the quality of life, which it improve the productivity of biodiesel production, which can generate the economic growth and sustain from the pollution. That's all from me. Thank you.